Ever stared at your terminal? You see a bunch of symbols, arrows, vertical bars, and you just think, what on earth is going on here? Well, you have come to the exact right place. Today, we're going to decode that secret language of the command line. We're going to give you the power to control exactly where your data goes. Okay, let's just dive right in. A command like this? Yeah, it can look pretty intimidating. I mean, you've got a normal command, find, and then this trail of what looks like cryptic numbers and symbols. Honestly, it's the kind of thing that separates someone just starting out from someone who truly commands their system. But what if I told you that by the end of this short explainer, every single piece of that command is going to make perfect sense? Seriously, you won't just understand it, you'll be able to build your own powerful custom commands just like it. So let's get started.
All right, so how do we get there? How do we become masters of this data flow? Well, it all starts with understanding the why behind it all. How the system actually keeps track of all this information that's zipping around. And the secret, the key to all of this, is a concept called a file descriptor.
So here's the core idea, and it's actually pretty simple. Every single time you open a file, or you run a program, or even just launch your terminal, the operating system assigns it a unique number. Think of it like a little tag. That number is the file descriptor, or FD for short, and it's literally how the operating system keeps everything organized.
And to make this concept really click, here's the best analogy. Think of it like the ticket you get at a cloakroom for your coat, right? You hand over your coat, you get a little ticket back. You don't need to know which rack it's on or who put it there. You just need to hold on to that ticket. Well, the system works the exact same way with your data.
The process maps perfectly. Step 1, you open a file. That's like giving your coat to the attendant. Step 2, the system gives you back a file descriptor. That's your ticket. Then later, when you want to access that file, you just present your ticket, the file descriptor, and the system knows exactly which coat to go grab for you. See? Simple, right?
Okay, so if the system is handing out these tickets, you might be wondering, do we get any for free when we start? And the answer is yes, absolutely. Every single program you run automatically starts with 3 default tickets already in its hand, and these are known as the standard streams.
Now, these 3 streams are the absolute foundation of all this. You've got ticket number 0, which is standard input, or STDIN. That's data flowing into your program, like from your keyboard. Then there's ticket number 1, standard output, or STDOut. This is where all the successful results of your command go. And finally, ticket number 2 is standard error, STDR. That's a special channel just for error messages. Seriously, remembering these 3 numbers, 0, 1, and 2, is the key to unlocking everything else.
Okay, so we've got our 3 default tickets, 0, 1, and 2. Now for the really fun part. We can actually tell the system to swap those tickets around, sending the data from any of those streams wherever we want. This is called redirection. And this, my friends, is where we really take control.
So let's look at a super practical example. On the left, we run a search, and what do we get? A big mess. It's a mix of actual results and a ton of permission-denied errors. It's just noisy. But now look at the right. We add this little piece, to/devnull. What this does is it tells file descriptor 2, remember, that's standard error, to send all its data not to our screen, but to the special place called /devnull. And /devnull is basically a black hole. Anything you send there is just gone. And just like that, poof, the errors vanish, leaving us with nothing but clean, useful output.
Okay, but what about the good stuff? The actual results? Well, we use the greater than symbol for that. This little greater than symbol redirects standard output. Now, you don't usually see it, but it's really shorthand for 1 greater than, telling the system to take everything from file descriptor 1 and send it into, say, a file called results.txt. And a quick warning, if that file doesn't exist, it'll create it. But if it does exist, it gets completely overwritten. So be careful.
But what if you don't want to overwrite your file? That's a super common problem, right? Maybe you want to run a few commands and gather all the results in one place. Well, for that, you just use a double arrow, double dash. This tells the system to append the new output to the end of the file, keeping everything that was already in there safe and sound.
And hey, redirection works the other way too. The less than symbol, less than, does the exact opposite. It takes the entire contents of a file and feeds it into a command's standard input. It's ticket number 0.
So in this example, it's telling the cat command, hey, don't wait for me to type anything. Just use the stuff inside standard.txt as your input.
Okay, redirection is really, really cool. But now we get to the real magic, the game changer. What if you want to take the output of one command and immediately, without creating any temporary files, use it as the input for a second command? Well, for that, my friend, we use the pipe.
This simple vertical bar, the pipe, slash, is honestly one of the most powerful tools in your entire terminal toolkit. What it does is create a direct, in-memory connection. It takes all that successful output, the SDOut, from the command on the left, and just funnels it, streams it directly into the standard input of the command on the right. No files, no fuss.
So let's build one of these pipelines right now. For step 1, we'll use our find command to get a big list of all the files in the etc directory that end with .conf. And of course, we'll bring back our old friend 2/devnull to keep things clean by silencing any permission errors. Okay, so running this alone would just spit out a huge list of file paths.
But now, for step 2, we add a pipe. See that? So that huge list of files isn't printed to the screen anymore. Instead, it's flowing directly into the grep command. We're basically telling grep to act like a filter. Only let the lines that contain the word systemd pass through. We didn't need a temporary file or anything. The data just flows seamlessly.
And we're not done. Let's add one more pipe for step 3. Now, that filtered list from grep flows directly into the wc-l command. That stands for word count lines. Now think about this. WC has no idea about the original find command. It only sees the list that grep gave it, and its only job is to count the lines. This is a perfect example of chaining tiny, simple tools together to do something surprisingly complex and powerful.
And after all that, finding files, filtering them, what's the final output? Just a single number. That's it. We went from a potentially massive list of files to a filtered list down to a final count, all in one elegant, super efficient command. And really, that's it. You've just unlocked a genuine command line superpower. This isn't just about learning to type a few fancy symbols. It's about a fundamental shift in how you work. It's about being more efficient, more precise, and honestly, way more powerful on your own system.
So, let's do a super quick cheat sheet to lock this all in. The single grader sends output to a file, but be careful, it overwrites. The double grader adds to a file, that's appending. The less than sign uses a file as input. The to grader is your secret weapon to redirect and silence errors. And of course, the mighty pipe connects one command's output to another's input.
When you put it all together, you're not just running commands anymore. You're like a conductor of a data orchestra. You can now precisely control the flow. You can silence the noise from errors, you can save your important results, and you can build these powerful tool chains on the fly, all without breaking a sweat. So remember that crazy-looking command from the very beginning? I bet it doesn't look so intimidating now, does it? You know exactly what it's doing. It's finding a file, it's hiding all the errors, and it's saving the successful result to a text file. You get it. So the only real question left is, now that you can command the flow, what are you going to build?